This is part 2 of the video on patterns and relationships found in right triangles. So we stopped at example 6, and what we had found on example 6 was that when this diagonal had a length of 8, that the side length was 4 to the square root of 2. Okay, and so now we have a quick check here that says now we're going to say that the diagonal is 18. So I want you to think for a minute and think if you might give a guess of what you think the answer might be. Okay, and then let's solve for it. So let's clear this. So now we're saying that this is 18, and so it's a square, so we don't know what the sides are, but we know they're the same. So we can call them x and x, and we can say x squared plus x squared is equal to 18 squared. So we get 2x squared is equal to, let me see, 18 squared is 324. So if we divide both sides by 2, we get x squared is equal to 162. So x would be equal to the square root of 162. So you'll find that we can rewrite 162 as 81 times 2. And the square root of 81 is 9. So this becomes 9 to the square root of 2. So maybe you'll see the pattern now. You erase this, and let me put a couple triangles here. So when we have these 45, 45, 90 triangles, those are the angle measurements. The first one we had was 8. I'm sorry, this was 8. And so let me erase this. The diagonal was 8, and so what we found was that this side was 4 times the square root of 2. And then when this was 18, this was 9 times the square root of 2. So if this is 45, 45, 90, and if this is 20, what do you think the side's going to be? It's going to be half of 20, which is 10, times the square root of 2. So hopefully you'll start seeing why this is called patterns and relationships found in right triangles. These patterns are always going to exist in these triangles that have measurements of 45, 45, and 90 degrees for their angles. Okay, so let's look at what's next. We have a side length of 10 to the square root of 2. So this time, this is 10 to the square root of 2. Okay, now we're looking for the diagonal. So we can solve. We can say a squared plus b squared, or 10 to the square root of 2 squared, plus 10 to the square root of 2 squared is equal to c squared. And we're going to find our diagonal. 10 to the square root of 2 times 10 to the square root of 2. 10 times 10 is 100. The square root of 2 times the square root of 2 is 2. 100 times 2 is 200. So this is 200 plus 200 is equal to c squared. 400 is equal to c squared. C is equal to the square root of 400, which is 20. All right, and so I'm going to show you in a little bit really how to set this pattern up, but let's look at a couple more that they give us here. Okay, the next thing is now we have an equilateral triangle. So this is also going to have a pattern, but it's going to be a little bit different. So here they're saying that each side of the equilateral triangle, at least this one, is 2 units. So they're saying that these sides are all 2. Well, when you have an equilateral triangle and when you draw the height, which is at a right angle, it cuts this base in half. So if this side is 2, this would be 1 because it's half. And now we want to find y. So we have a squared plus b squared is equal to c squared. So I'm going to say 1 squared plus, this side here we're calling y squared is equal to 2 squared. So 1 plus y is equal to 4. Subtract 1 from both sides, we get y squared. Y squared is equal to 3, and so y is equal to the square root of 3. Okay, so x is 1, y is the square root of 3. Now these angle measures are also important. We know that this one's 90, and in an equilateral triangle, these are all 60, but again, when you draw the height, it cuts the top one in half. And so now this triangle is what we will call a 30, 60, 90 triangle. And that is going to be the other triangle that gives us a special relationship that's going to be consistent that we can solve for. Okay, so E is 30 degrees and F is 60. Let's look at the quick check. Each side is 4. So if these are 4, half of 4 is 2. So x is going to be 2. Wonder if anyone wants to try and guess what y might be. Well, let's solve for it. A squared plus b squared is equal to c squared. 2 squared plus y squared is equal to 4 squared. 4 plus y squared is equal to 16. If we subtract 4 from both sides, y squared is equal to 12. So y is equal to the square root of 12, which can be rewritten as 4 times 3. And so the 2 comes out, the 3 stays under, and so y is 2 times the square root of 3. Okay, this is 2 times the square root of 3. All right. Let's see. Okay, let's go on down to the very bottom here and let's fill this out because I think it will help now. So here are our special right triangles, and these are going to be the relationships that always exist. And they're called special right triangles because they're going to be special. Now it says to record any observations that we've made, and we're going to label these diagrams. So let me just do that for you here. This first one is what we're going to call the 45, 45, 90 triangle. So the interior angles are 45, 45, and 90. And so we measured the angles. The lengths of the two legs are the same because it's a square. So we're going to call those x. Well, the length of the hypotenuse is going to be the product of the length of the leg and the square root of 2. So in other words, we're going to have x and x times the square root of 2. So whatever the side length is of that square, the hypotenuse is going to be that times the square root of 2. Okay, and this is a pattern that will exist. Let's see. So just you can write that down, and we'll work with this for quite a bit. Now let's look at the other one, which is we will call the 30, 60, 90 triangle. Okay, so these interior angles are 30, 60, and 90. Now this one you have to be a little more careful, okay? Because the length of the hypotenuse is always going to be twice the length of the shorter leg. And the length of the longer leg is equal to the product of the length of the shorter leg and the square root of 3. So in other words, the way that we can label this triangle is the side across from 30 will be x, the hypotenuse will be 2x, and the side across from 60 will be x times the square root of 3. Okay, so those are the rules, and then we are going to work on this practice in class tomorrow. Thank you.